Have you ever looked up at the night sky and wondered, are we alone in the universe? This is a question that has captivated the human imagination for centuries. The concept of alien life, of civilizations beyond our own, is a thought that's as fascinating as it is profound. The existence of extraterrestrial intelligence isn't just a matter of curiosity. It speaks to the very essence of who we are, our place in the cosmos, and the nature of life itself. Think about it. If we're not alone, if there are other intelligent beings out there, it would redefine our understanding of life, intelligence, and the universe. It would mean that life is not a unique phenomenon confined to our tiny blue dot, but a cosmic occurrence, potentially as common and varied as the stars themselves. But where do we start in our search for these alien civilizations? How do we navigate the vast expanse of the cosmos to find them? And most importantly, how do we even begin to comprehend what such a discovery would mean for us? Join us as we embark on a journey to answer one of the most profound questions of our time. Given the vastness of the universe, why haven't we encountered intelligent extraterrestrial life? This question is at the heart of what we call the Fermi paradox. Named after physicist Enrico Fermi, this paradox grapples with the contradiction between the high probability of alien life and the stark lack of evidence or contact. You see, with billions of stars, each potentially hosting planets, the odds seem to favor the existence of extraterrestrial civilizations. Yet, despite our increasingly sophisticated technology and the relentless search for alien life, we've come up empty-handed. This silence from the cosmos is puzzling. Some argue that intelligent life might be avoiding us, or that they've come and gone, or perhaps we're just not listening in the right way. Regardless of the reasons, the Fermi paradox forces us to wrestle with our place in the universe and confront the possibility of our solitude. This paradox leads us to the question, where is everybody? How can we estimate the number of potential alien civilizations in our galaxy? To tackle this question, scientists turn to the Drake equation. Named after the astrophysicist Frank Drake, this equation is a probabilistic argument used to estimate the number of active, communicative, extraterrestrial civilizations in the Milky Way galaxy. Imagine a vast cosmic lottery. The Drake equation lets us estimate the odds. It factors in variables like the rate of star formation, the fraction of those stars with planetary systems, the number of planets that could potentially support life, the fraction that could develop intelligent life, the proportion that could produce signals detectable across interstellar distances, and the length of time such civilizations could broadcast these signals. It's a mathematical tool that allows us to play with possibilities. Keep in mind, though, the equation is not definitive. It's a way to frame our ignorance and make educated guesses about the cosmos. The Drake equation gives us a way to make educated guesses about the existence of extraterrestrial life. What makes a planet suitable for life? This question has spurred the quest for exoplanets, planets that orbit stars outside of our own solar system. While the first exoplanet discovery was made as recently as the 90s, today we know of over 4,000 of these celestial bodies, and the number keeps growing. But not all exoplanets are created equal when it comes to the possibility of harboring life. This is where the concept of the Goldilocks zone comes into play, also known as the habitable zone. This is the region around a star where conditions might be just right, not too hot, not too cold, for liquid water to exist on a planet's surface. And where there's water, there could potentially be life. The Goldilocks zone is based on the distance of a planet from its star. Too close, and any water would evaporate in the intense heat. Too far, and it would freeze in the frigid darkness. But in that just right middle ground, liquid water and potentially life could thrive. But the Goldilocks zone isn't a guarantee of life. Other factors come into play, like the planet's atmosphere and its geological activity. A planet could be in the perfect spot, but without an atmosphere to trap heat and protect it from solar radiation, or geological activity to recycle carbon and keep the planet warm, it might still be a barren wasteland. So how do we find these potentially habitable exoplanets? Well, there are a few methods. One is the transit method, where we observe a star's light dimming as a planet passes in front of it. Another is the radial velocity method, where we detect the slight wobble of a star caused by the gravitational pull of an orbiting planet. The discovery and study of exoplanets, especially those in the Goldilocks zone, is a fascinating and vital part of our quest to answer one of the universe's biggest questions. Are we alone? Each new discovery brings a fresh wave of excitement, and the tantalizing possibility that maybe, just maybe, we might find a planet that's not too hot, not too cold, but just right. The search for planets in the Goldilocks zone brings us one step closer to finding life beyond Earth. How do we search for intelligent life in the universe? Well, the question has driven countless scientists, thinkers, and dreamers throughout history. Today, one of the most dedicated efforts to answer this question is spearheaded by an organization known as SETI, which stands for the Search for Extraterrestrial Intelligence. SETI's mission is as vast as the cosmos itself, but at its heart, it's quite simple. They're listening. They're scanning the skies, sifting through the cosmic noise, hoping to pick up a signal, a beacon, a cosmic hello, from an intelligent civilization out there in the great expanse of space. To do this, SETI employs a range of cutting-edge technologies. They use massive radio telescopes like the ones at the Green Bank Observatory in West Virginia and the Arecibo Observatory in Puerto Rico to scan the skies. These technological marvels are capable of detecting even the faintest radio signals from deep space. But what exactly are they listening for? Well, they're on the lookout for what scientists call narrow-band signals. These are radio signals with a very specific frequency, not typically produced by natural cosmic phenomena. If we detect such a signal, it could be a sign that it was intentionally produced by an intelligent source. Now you might be thinking, but space is so vast, how can we possibly scan it all? And you'd be right. The task is monumental, but it's not impossible. SETI uses a strategy called targeted search, where they focus on specific star systems that have the potential to host habitable planets. These are the places where we think life, as we understand it, could potentially exist. Despite the monumental challenge, the scientists at SETI press on, driven by the tantalizing possibility of making one of the most profound discoveries in human history. Yes, the search for extraterrestrial intelligence is a daunting quest. It's like trying to find a specific grain of sand on a beach that spans the entire globe. But the very fact that we are searching, that we are reaching out into the cosmos with open minds and open ears, speaks to something deeply human. The quest of SETI is a testament to our enduring curiosity about the universe and our place in it. Have we ever received a signal from an extraterrestrial civilization? This is a question that has intrigued and puzzled scientists, researchers, and curious minds for decades. Throughout our history of scanning the cosmos, there have been moments that piqued interest and raised eyebrows. Let's take a trip back to the year 1977, to the Big Ear Radio Telescope at Ohio State University. An astronomer, poring over the printouts from the observatory, came across a signal affectionately dubbed the WOW signal. This signal, a burst of radio waves that lasted for about 72 seconds, was so strong and so distinct that it seemed to be something other than a natural cosmic phenomenon. Yet, despite repeated attempts to locate the signal again, it has remained a one-time anomaly. Fast forward to the first decade of the 21st century. Scientists detected mysterious high-energy blasts known as fast radio bursts, or FRBs. These bursts, originating billions of light years away, flash for just a millisecond, yet generate as much energy as 500 million suns. The sporadic and random nature of these bursts, combined with their enormous energy, have fueled speculations about their possible artificial origins. Just a few years ago, in 2017, our solar system was visited by Oumuamua, an object from interstellar space. Its odd, elongated shape, its shiny surface, and its unusual acceleration as it passed our sun led some to propose that it might not be a natural object, but a piece of alien technology. And then there are the unexplained periodic dimming of certain stars like KIC 8462852, also known as Tabby's star, that have left scientists scratching their heads. Could these be Dyson spheres, megastructures built by advanced civilizations to harness the energy of their stars? While none of these signals or anomalies have been definitively proven to be of extraterrestrial origin, they serve as tantalizing hints of what might be out there. They continue to inspire us, to drive our curiosity and our search for answers. These signals and anomalies keep the question of extraterrestrial life alive and exciting. Have there been credible sightings of unidentified flying objects? Let's delve into the annals of history. One of the most famous sightings came from Roswell, New Mexico, in 1947. A rancher discovered unidentifiable debris in his sheep pasture, sparking rumors that an alien spacecraft had crashed. The military insisted it was a weather balloon, but the story has kept Roswell in the UFO spotlight ever since. Another notable sighting occurred in 1952, when a series of mass UFO sightings took place in Washington, D.C. Radar screens picked up a flurry of unidentified objects moving in such a way that no known aircraft could. The event caused a nationwide sensation, and while the Air Force attributed the phenomena to temperature inversions, many remained unconvinced. Then, there's the Belgian UFO wave in 1989, where thousands reported seeing large, silent, low-flying black triangles. The Belgian Air Force could not explain the phenomena. While these sightings remain unexplained, they continue to fuel our fascination with the possibility of extraterrestrial life. With our expanding knowledge of the universe, how does the Drake equation hold up? Well, let's revisit this fascinating expression. As you may recall, the Drake equation provides a rough estimate of the number of potential extraterrestrial civilizations in our galaxy. It's like a cosmic bingo card, with each variable representing a condition necessary for intelligent life. But as we learn more about our universe, these variables are subject to change. For instance, our discovery of exoplanets has dramatically increased the value assigned to the number of habitable planets per star. Similarly, our understanding of life's resilience, thanks to extremophiles, broadens the definitions of habitable conditions. However, the Drake equation isn't a crystal ball. It's a tool for framing our understanding and stimulating conversation. It's not about pinpointing an exact number, but about exploring possibilities. So as our knowledge grows, the equation evolves, reminding us of the vast potential for life beyond Earth. Our evolving understanding of the universe continues to influence our estimates of alien life. Could life exist in the most extreme conditions on Earth and beyond? This is the question that leads us to the fascinating study of extremophiles, organisms that thrive in conditions too harsh for most life forms. From the scorching vents of the deep sea to the freezing Arctic tundra, these hardy creatures defy our traditional understanding of life's prerequisites. But the existence of extremophiles doesn't just expand our knowledge about life on Earth. It also opens up the possibility of life on other celestial bodies within our solar system. Think about it. If organisms can survive in Earth's most hostile environments, couldn't they also endure the extreme conditions on planets like Mars or moons like Europa? The discovery of these resilient life forms not only challenges our definitions of habitability, but also shapes our search for extraterrestrial life. Because, after all, if life can persist in Earth's harshest conditions, who's to say it can't exist elsewhere in the cosmos? The existence of extremophiles expands our understanding of where life can thrive. What would it mean for humanity if we made contact with an extraterrestrial civilization? Picture this. A civilization not of our Earth, reaching out across the cosmic void, making contact. What might they tell us? What might we learn from them? The implications are staggering. Firstly, it would confirm we are not alone in the universe. This realization could unite us as a species, highlighting our shared humanity. Secondly, it may force us to reevaluate our place in the cosmos. Are we the cosmic equivalent of toddlers, or are we peers among the galactic community? The technological implications are also profound. Alien technology could leapfrog us centuries, even millennia, into the future. We could learn new ways to harness energy, travel faster than light, or even manipulate the fabric of space-time itself. Yet the contact could also bring risks. The history of contact between civilizations on Earth is riddled with conflict and devastation. Contact with an alien civilization could be a turning point in human history. The search for extraterrestrial life is both a scientific endeavor and a philosophical journey. We've roamed through the mysteries of the Fermi paradox, wrestling with the silence of the cosmos despite the seeming abundance of habitable worlds. We've decoded the Drake equation, a mathematical forecast of potential galactic neighbors. We've journeyed to the far reaches of our galaxy, visiting exoplanets in the Goldilocks zone, where conditions could be just right for life. We've joined the ranks of SETI, the search for extraterrestrial intelligence, as they scan the heavens for alien signals, and we've pondered the significance of unexplained anomalies and enigmatic UFO sightings. We've revisited our Drake equation, updating it with new discoveries and insights. We've even explored the idea of alien life right here on Earth in the form of extremophiles. and speculated on the existence of life on other celestial bodies within our own solar system. We've delved into the profound implications of making contact with an extraterrestrial civilization, a moment that would undoubtedly reshape our understanding of our place in the universe. We've traveled far and wide, yet the question remains as tantalizing as ever. As we continue to explore the cosmos, we continue to ask, are we alone? Thank you for joining us on this journey through the cosmos. We've dived into the depths of the universe's biggest mysteries and pondered the existence of alien life. We invite you to continue exploring with us. If you've enjoyed this cosmic adventure, please give us a thumbs up and share this video with your fellow space enthusiasts. And don't forget to hit that subscribe button and ring the bell to stay updated on our latest explorations into science and the cosmos. Keep looking up and keep asking questions.